Hi, welcome back to the channel. Okay, the questions that I have right here from this worksheet questions to do with interpolation. Okay, so there are several interesting questions from question 1 up to question 12. Okay, so in this video, what I'm particularly focusing on is question 10, which says given the data, like this data that we have here, 0, 0, 1, 1, as well as 2, 4, fit a quadratic spline to the function f defined by this set of points and use it to approximate f of 1.5. Okay, so one thing that stands out first of all is the fact that we are talking about a quadratic spline. Okay, so that's what one thing that we have to really keep in mind. Okay, so let's get to work this out and see. So we are given this data. Okay, you are given the data 0, 0. Okay, your another point you are given is 1, 1. Another data point that you're given is 2, 4. So one thing that you have to note down is that this one here is our x naught, this is our x sub 1, and this is our x sub 2 here. So it's more like if you look at the data set that we have here. Okay, so for this one, that 0 there that you have is the output of the input 0. Similarly, for this part, this one is the output of this input that you have here. Okay, so same as the 4 is the output of this input. Okay, so it's just more like you have a function. Let's say y is equals to some value x or anything, and like when you plug in a value here of x, let's say it is this one here, then you get the result which is also 1. That's what I was trying to put across there. Okay, so how do we go about approximating f of 1.5, because that's what the question is asking of us to do. So one thing that you have to do right now is to come up with a set of piecewise functions. Okay, so the way we are going to illustrate this is we can say our s of x. Okay, it can be this set of functions as of quadratic splines. So this is going to be s sub 1 rather. S sub 1 of x is equals to this is going to be a naught plus b naught x. Okay, b naught times x plus c naught times x squared, like that. Then you have another one which is going to be s sub 2 of x, which will be equals to a sub 1 plus b sub 1 x plus c sub 1 x squared. So the conditions that are for these is that they are going to be sets of intervals. This is where you have your x being in the interval x naught comma x1, like that. So for this one, it will be when x is between x1 and x2. Okay, and if you get these points that you have here, you can clearly see to say for this part, the coordinates that you have, or the points that you have, for your x naught is 0, your x1 is 1, like that. Then for this part, your x sub 1, okay, is a 1, then your x sub 2 is a what? Is a 2, from these points that I have here. Okay, so how you come up with these piecewise functions or piecewise expressions is there's a generalized formula that we use, but for now we're just going to focus on this. But basically it's just more like it's written as s sub n of x is equals to, you're going to have your a sub n minus 1. Okay, then you have like b sub n minus 1 multiplied by x, and then that will be c sub n minus 1 x squared, like that. So this is how those came about, because if you get 1 here, so it's more like I started from n is equals to what? N is equals to 1. Okay, so if I get 1, I plug in 1 here. This is going to be s sub 1. Okay, is equals to, if I plug in 1 where there's n here, this will be a sub 0, and that's how we came up with those. So this is just more like the generalized expression that we use to come up with those piecewise functions. So having done this, the first thing that we are supposed to do is to apply interpolating conditions or interpolation conditions. So you have to apply uh, interpolation conditions interpolation conditions. Okay, that's the first thing that you have to do. After you have done this here, the first thing, the what follows is you have to do this. Let's now get to the way we do this. So this is a very simple and basic step. You just have to take things like step by step. Okay, so one thing here that without even wasting time that I can show you is the fact that, remember, initially what we are looking for is to approximate f of 1.5. So it's more like at the end I'm going to have two sets of functions, this one as well as this one, but let's just say I'm going to use this one to approximate f of 1.5. So this is the way this is going to be. Is more like if I'm using the second one, I'm going to say s sub 2 of 1.5 is equals to, so this would be a sub 1 plus b sub 1 multiplied by 1.5 plus c sub 1 multiplied by 1.5 squared. So this is what is going to help me to approximate what f of 1.5 is, because all of this is just equals to f of 1.5, and I'm going to find a certain value. Let me just say lambda, like that. Okay, yeah. So what we are looking for, if you have observed, we're just looking for a sub 1, b sub 1, as well as c sub 1. So how do we go about finding these coefficients? So if you look at the first one, if you focus just on this first equation, this one here, this first equation, so you're going to say for your first one, s sub 1, okay, you're going to evaluate it at the first point, which is this one at x naught. Okay, and our x naught is what? Is a 0. So this is going to be you're going to say 0 here is equals to, what's the result? Okay, so if you say f of 0 here, what is the output? The output is this one. It's also what? It's also 0. So this one is also equals to 0, like that. Okay, so you have evaluated for this part. Let's now look at this part here as well. So this is just going to be more like a naught plus b naught, and remember, you are evaluating at x is equals to x naught. And what is our x naught? Our x naught is equals to 0. So even here, you just plug in 0 here, you just plug in 0. So it simply means b naught as well as c naught are going to, like, you have 0 here and you have 0 here. So this tells us that you don't even have to actually put it here like this. Okay, so because you're going to have like plus 0, and yeah, it's just like that. So that's what you're going to have for that part. And keep in mind to say this expression here is equals to this expression. So it simply means this one here is equals to that one. What does this tell us? This tells us that a naught is equals to 0. Okay, from here. So let's go to the second one. So for the second part, what we do is that we're going to say s sub 1 of, you're just evaluating at this point. So I've already evaluated at x naught. Let me now evaluate at x1 there, like that. Okay, so what is our x1? Our x1 is 1 is equals to, so when you get to these points, when you say when x is 1, what is the output? The output is 1 as well. So meaning this is equals to 1. Okay, so now let's look at let's look at this part. So what we do on this part is that where there's x here, substitute 1. Even here where there's x squared, substitute what? Substitute 1. And one thing that you're going to end up with is just something like a naught plus b naught plus c naught, like that. Then you have to equate this one with this one, because we know that to say this part is equals to this part. I've evaluated for this one and I've ended up with 1. Then after evaluating for this one, I end up with what? I end up with this one here. Okay, so, and one thing again that can be used to simplify is the fact that where you have a naught here, you know to say a naught in the first part is equals to what? Is equals to 0. So what this gives us is just the fact that your b naught plus your c naught is is equals to is equals to 1. Okay, so we keep on forming equations from here. So now we are done with evaluating the first piecewise function with respect to the coordinates that we are the coordinates that we have here, like this interval rather. So let's go to the second one now, which is s sub 2. So your s sub 2 of the first point we evaluate it at is at x naught, I mean x sub 1 rather, which is this one here. So this is going to be equals to, it's equals to 1 as well, because when you plug in 1, the result is supposed to be what? It's supposed to be 1, or it is 1 as it is given. Okay, so in this one, what it means is that where you have x, substitute 1. Even here where you have x squared, substitute 1. So this is just going to be a sub 1 plus b sub 1 plus c sub 1. Okay, so you have to this one equated to that one there. Okay, and what you're going to end up with is a sub 1 plus b sub 1 plus c sub 1, which is equals to 1. Okay, let's go to the last one. Okay, not really the last, but yeah, but the more like the last point on the interval that we are given on the second one. Okay, so this is our s sub 2 there, and this is our 1. So s sub 2 evaluating at what? At x2, which is this one here. So what is our x2? Our x2 is 2. So this will be 2. And when you come to these coordinates here, like these coordinates that you have, when your input is 2, what is your result? Your result is 4. So meaning this one is equals to 4. So here it simply means where there's x, you substitute what? You substitute 2. So for here, for this x, that's just going to be 2. Then 2 squared is a 4. So meaning this one is just going to be a sub 1 plus b sub actually 2b sub 1, 2b sub 1 plus 4c sub 1 there. Okay, so the result that we get here is this is going to be a sub 1 plus 2b sub 1 plus 4c sub 1 is equals to 4. So now we have these equations, and we don't end there. There are 2 steps that we can also take, that we should also take actually, for us to simplify this. Okay, so now we have applied the interpolation conditions. What I've done here is just you applying the interpolation conditions. Okay, and how many equations do you have? You have this one, you have this one, and you have this one. Okay, so let's apply 2 more, but no, they are not interpolating conditions, so I'll just have to erase this part. So for this part, we were applying interpolating conditions, and we have gotten some reasonable results, which includes the fact that we said, or we came up with the fact that a naught is equals to 0. Then another one that we have is that b naught plus c naught is equals to 1. Okay, so let me just put a demarcation here so that we don't confuse ourselves there. Okay, then we have also found the fact that a sub 1 plus b sub 1 plus c sub 1 is equals to 1. Then for the last part, after the on the interpolating conditions, is the fact that a sub 1 plus 2b sub 1 plus 4c sub 1 is equals to 4, like that. Okay, so now one thing that we also have to apply is a derivative condition. Those were interpolating conditions. Now we have to come up with the we have to apply the derivative condition. Okay, so for the derivative condition, for the derivative condition, you have to ensure that the function is continuous at the interior points. Okay, those interior points that I'm talking about, they are just not interior points. You can also see them as what? As knots. Okay, so what I mean by those knots is that I'm talking about this point here, this one as well as this one here, because when you look at those 2 piecewise functions, it's like the point at which they are intersecting, if you'd want to see it that way, is at 1. So it's like you're going to you have something like you have 0 comma 1, okay, and you have 1 comma 1 comma 2. Those interior points are these ones here. Okay, this is unlike when you're talking about cubic splines, where you are going to look at the boundary conditions. For cubic splines, if you look at boundary conditions, you're going to be focusing on this point as well as what, as well as this point. So the interior points in this case is this one and this one here. Okay, so that's that about the derivative condition. So what this tells us that this is just going to be more like you're going to say your s prime, okay, your s prime of your s prime of, let me use your s prime of j, okay, your s prime of j of x should be equals to your s prime of j plus 1 at x. So this x here that I'm talking about is the interior condition that I talked about. So what's different about this? So here the condition that I'm going to put for j is that your j should start from what? Should start from 1, and that is because of what I have here. So it simply means here your s prime of 1, if j is equals to 1, of x is should be equals to your s prime of j plus 1 is what? Is a 2 of x. So it simply means the derivative of this is supposed to be equal to the derivative of that, and that is evaluated at the interior point, which is 1 there. So all you have to do is just differentiate these functions that you have. So your s prime, okay, your s prime of 1 of x is simply going to be equals to your a naught is going to give you 0. Then here you're going to have b naught plus, and that would be 2 c naught times x. Okay, then the derivative of this one here, this is just going to be equals to s prime of 2 here of x is equals to your a sub 1 is going to be 0, and that's just going to be b sub 1 plus 2c sub 1 of x. So you just have to equate this one with this one, and ensuring to say your x is equals to the interior is equals to the interior condition there. Okay, that is our x there, like that. So you have your b naught plus your 2 c naught x is equals to b sub 1 plus 2c sub 1 of x. And remember, your x is equals to what? The interior condition, which is this one here. Okay, so you can say b naught plus it will be actually 2c naught, okay, is equals to b sub 1 plus 2c sub 1. That's another equation that you have. Okay, that's another equation that you have. So we can say another equation that we have ended up having is b naught plus 2c naught is equals to b sub 1 there is equals to, oh no, I mean plus 2c sub 1 there, like that. Okay, so this is the derivative condition when it comes to quadratic splines. So another thing that you can do is, like, the last thing that you can do is you have to find the derivative of s sub 1 evaluated at x naught. So when you do that, you have to equate it to 0. So that way you're just trying to simplify all of this, because we have a lot of unknowns here. So what we want to try to do is to simplify everything. So what we do is differentiate your s sub 1, then evaluate it at x naught. So it's like let me say it this way. Not just differentiating, actually, you differentiate for the second time, because we have already differentiated to say we have found that s prime of 1 of x is equals to, we found that it was b naught plus 2 c naught x. So you have to find the second derivative rather. So it will be s prime of s sub 1 here to be equals to, so the derivative of this with respect to x is simply c naught. But you have to evaluate this at what? You have to evaluate this at x naught. And what is our x naught? Our x naught is equals to 0. So it simply means when you evaluate this at x naught, we don't have any x here. Then when you equate it to 0, this is just going to indicate to say your C naught is equals to what? Your C naught is equals to 0. So that's another thing that we have found that has simplified, that is going to simplify our work here. So our C naught is equals to 0. Okay, so now let's start simplifying things here. So if my C naught is equals to 0, it simply means for this part here, I can find my B naught. Okay, so if this is 0 here, it simply means my B naught is just equals to 1. Okay, so it simply means that part my B naught is just equals to 1. I've simplified this. So another thing that we can do is that we can work out for this one. We can plug in 1 here, then we plug in 0 here, then it simply means your B sub 1 plus 2 C sub 1 is equals to 1. So one thing I can do is that I'm remaining with these two equations now, as well as what? As well as this third one. So for simplicity, I can make B sub 1 the subject to the formula. So your B sub 1 will be equals to 1 minus 2C sub 1. So I'm going to substitute in this equation as well as this equation, so that I get rid of the what? Of the B sub 1, meaning I'm just going to remain with two unknowns, which is going to be A sub 1 as well as C sub 1. So if I say A sub 1 in this one, where there is B sub 1, I substitute plus 1 minus 2C sub 1 plus C sub 1 is equals to 1. Then in this one, like in the second one, which is this one here, let's substitute as well. We have A sub 1 plus, while there is B sub 1 here, we substitute with 1 minus 2C sub 1, and remember there is a 2 outside here, so just going to multiply this by 2. So 1 by 2 is a 2 minus 2 by 2 is a 4C sub 1 plus 4C sub 1 is equals to 4. So one thing you observe is that this and that can go. So these two, when it's subtracted on both sides, you just end up with A sub 1 being equals to 2. So we have A sub 1 is equals to 2. We have simplified it there. So another thing that we can actually find is one thing that we can find is the fact that we have found our A sub 1. Let's now try to use this one to find our C sub 1. So because when this one is subtracted on both sides, you get a 0 here. So this is just going to be A sub 1 minus C sub 1 is equals to 0. If you plug in 2 here, when this one goes on the other side, it's negative, meaning your C sub 1 is equals to positive 2 as well. So it is simplifying so smoothly. So here your C sub 1 is equals to 2 as well. Now let's find our B sub 1. So we said our B sub 1 is equals to 1 minus 2. Our C sub 1 is a 2. So you have B sub 1 is equals to 1 minus 4, meaning this is equals to minus 3. So your B sub 1 is equals to minus 3. Okay, so now we have everything that we need. So it simply means for these equations, S of x, this is just going to be equals to, for this part you have your S sub 1 of x is equals to, your A naught is 0. Okay, your A naught is 0, your B naught is 1, your C naught is also 0. So meaning this is just going to be equals to x, and this is at x in the interval 0, 1. Then your S sub 2 of x, it will be equals to, so your A sub 1 is a 2 plus, but rather your B sub 1 is negative 3, so that will be negative 3x plus your C sub 1 is also a 2, so you have 2x squared, and that is in the interval 1, 2. So those are the quadratic splines here that we are going to use. So it's actually this one that is going to give us the correct approximation. Remember, we're talking about quadratic splines here. Okay, so it simply means for us to evaluate f of 1.5, we're just going to say it will be S sub 2 of 1.5 is the same as f of 1.5, which is equals to, so just substitute, you have 2 minus 3, 1.5, then plus this will be 2, you have 1.5 squared. Okay, so if you do your math correct there, you're just going to have like it to be 2 here minus 3 times 1.5 is 4.5. Okay, so 1.5 times 2, sorry, 1.5 squared times 2, it's plus 4.5, meaning the answer is just 2. So your f of 1.5 is actually a 2, and that's your answer. And that's basically how we get to answer this question. Thank you very much for watching.